All right, this is going to be AP Calculus Lesson 5-5. We're talking about trigonometric antiderivatives, so trig functions. Where are we in our unit? So 5-5, standard L, that is right here, trigonometric antiderivatives. We are halfway through the unit after we get halfway through this lesson. So we'll be over halfway done after the end of this lesson. All right, so there's a setup, make sure it's copied down. Let's talk about some general, or not general, the different types of antiderivatives that we know, some review. So in general, if I have some function prime of an inner, what does that turn into when I take the integral of it, when I take the antiderivative? So this is going to be what? It should be that same a times f in parentheses plus c. You just get rid of a prime. And we'll make a note here, if I have an integral of af, this is going to turn into a capital F in parentheses. A capital F means I'm going backwards from our normal f. All right, so let's move to our power. Review of what happens when we take the antiderivative of powerhouse. Powerhouse means I'm going to add 1, so I have that same a, oh, I want to change my color back to blue. I have that same a to the power, there's the inner, and then n is going to be added, and then I'm going to divide everything by that n plus 1. So I add 1 to the power, and then I divide down. All right, what about unique power? So when I have a times the inner to the power of -1, we just learned this last lesson, and this is going to be a times, what is this again? Do you remember from last lesson? This is going to be the natural log of that inner, oh, I forgot my plus c up here, plus c, and just a bit of review for natural logs too. So how do I get to, what was one of those common questions on the AP test? So antiderivative of 1 over x, always remember that that turns into natural log of x. Other thing that we need to know that the natural log of e, what is that? Natural log of e, is that 0? Is that 1? Is that infinity? What is this thing that is 1? Natural log and e, they kind of cancel each other out to leave a 1. How do I get, or what's this one? Natural log of 1. Natural log of 1 is 0. Okay, you need to know all of these as well in the sidebar. All right, so moving on to e-house, treehouse, we're talking about this inner on the top. So what is this going to turn into? That's going to be my same a, e, and its e-house stays the same, to the power of whatever plus c. And then how do I know when to use u substitution? These are the general house, or not the general houses, these are all the different houses that we've learned so far to go backwards. When do we use u substitution? When do we use taxman? And we'll make a note here. And I shouldn't really be doing this in red because we already know this, but this is important. So you use u, I'm just going to say u substitution, u sub, when do you do this? When the inner, sorry, not inner, when dinner is not equal to 1. So you always look at that inner, whatever is inside the parentheses. If you take the derivative of that and it's not equal to 1, you need to use u substitution. And the quick way that we did that was using taxman. Perfect. All right, let's talk about some trig antiderivatives. So trig antiderivatives. All right, so there's 3 of them that we need to know, and here they are. There's the integral of a sine of the inner. Okay, what is that going to be? And before I touch on this, let's go ahead and think about how to go forwards with trig. So d dx, the derivative of sine of the inner. What did that turn into? And you're thinking, okay, cosine or negative cosine. I forget which one it is, maybe. So we'll write the cosine. And so this is the derivative of s. S is for same sign. So if this was a positive, this is also positive. That's the answer. Let's look at the other one, d dx of cosine of the inner. That's going to turn into and you know it's going to be sine, but you forget maybe if it's going to be negative or positive sign. So C, the C here says change the sign. This is going to be a negative. Okay, and the other one that we learned was that the derivative, I don't actually know if we learned this one, but the derivative of tangent will turn into secant squared of the inner. Okay, so coming back here then, the integral of this sine function is going to be some constant times the sine. This is going to be the anti-same. Anti-same means change. So change the sign. Change the sign. If this was a positive, it's going to become a negative. So this is negative a cosine of the inner, and don't forget your plus c. Let's take a look at the second out of our third function. So we have a cosine of our inner. That's going to turn into, now let's read this. This is going to be the anti-change. Anti-change means same, so same sign. This is going to be a sine of inner plus c. And let's think about what this means. So if I go backwards, if I take the derivative of cosine is going to be a negative sign. A negative sign will make a positive sign. So that works going backwards. And taking a look at this one, if I take the derivative of sine turns into a positive cosine. So that also works. The signs, or they match up to going forwards. And last but not least, we have our a times secant squared of the inner. What is this thing? And I'm only 90% sure again that we have learned this, but I think we have. Going back from secant squared is just tangent. So a times, not tangent, there we go, a tangent of the inner plus c. These three things we need to now memorize. Okay, I have two examples and then we can finish. So let's do example one. It might take the rest of the slide. I might have to go to the second slide, but examples. Number one. Let's take the integral of 5 sine of 10x dx. Okay, so again, when we talked over here, u substitution when dinner is not equal to 1. What is dinner? Dinner is 10. It's not 1, therefore we're using u substitution. Let's go ahead and find u. So here we go. U is going to equal 10x. That means du dx, du with respect to whatever this is, which is dx, is going to equal 10, and therefore we can find our dx that we need to get rid of. This dx is going to equal 10 divided by no, that's not right. Du divided by 10. Du divided by 10. And then from there, that allows me to change this equation to make it a little bit easier. This is still going to be integral of 5, and then sine of, and then 10x becomes u, and then dx becomes du over 10. Du, and I'm going to write over 10 over here, because it makes more sense. All right, so simplifying this a little bit more, and we get 1/2 sine of u du. I am still taking the integral. All right, so now I take the antiderivative. My a, in this case, my a here is 1/2, and then I have my sine of my inner, and this is going to become, after I take the antiderivative, anti-same is change the sign. That's going to be a negative 1/2, and then the sign changes to a cosine. Cosine of the inner, and no more du. Du goes away when I take the integral of it. And now I need to add my c. Perfect. Almost done. I need to get rid of the u. So final answer after plugging in my u is negative 1/2 cosine. U again was 10x plus c. There it is. All right. And our second example. Here we go. Numero dos. Let's do this problem. Negative 1/3 times the integral of cosine of 4x dx. Always remember our dx. All right, do we need to use u substitution? Well, what question are we asking ourselves? We have to use u substitution when derivative of inner is not equal to 1. Dinner here is 4. 4 is not equal to 1, therefore I'm using u substitution. Here we go. So change to blue here. Let us know that we're working on this problem. So u, we need to find that. Come on now. U, we need to find du with respect to this thing, dx. And then that will solve for this dx. dx. All right, so what is u? U is the inner, that's 4x. The derivative of 4x is 4. Solving for dx in this equation is du divided by 4. All right, rewriting this equation with respect to du's and u's. No more x's. I still have my negative 1/3. I still have my integral. Still have my cosine. But now, instead of a 4x, I have a u. Instead of a dx, I have a du over 4. du, and there's not really a good place to put it over 4, so I'm just going to put it right here. And don't forget my, oh, I still have my du. I don't need to rewrite anything. All right, so this is a cool little trick that I can show you guys that you might not have seen before. You can actually pull constants whenever they're being multiplied. You can pull constants out of this integral. So by doing that, this is going to look like negative 1/12. I pull the 4 out with a 3. The integral of cosine u du. I didn't have to pull it out. I could have just left it 1/4 cosine u. I'll get the same answer. It just is a cool trick that you should know. All right, so from here, what am I going to do? I still have my negative 1/12. And now I'm going to take the antiderivative of cosine of u. So anti-change means same. So same sign. So don't worry about changing positives or negatives. It's the same. And cosine turns into a sine. And I was about to write u, but I'm just going to skip that step. U is 4x. And don't forget your plus c. All right, so there's our final answer. Negative 1/12 sine of 4x plus c. All right, is that all that we have for the notes? That is all of it. All right, so go ahead and write your summaries and work on the worksheet. I'll see you guys on Monday, unless, of course, Riley is born. All right, later.